If you joined us in January, we showed you a few charts displaying a few oscillations and their teleconnections between their current phase and the effects on the climate. Today, we will look at two oscillations and again focus on their phase and effects on the climate. Remember that a teleconnection refers to a recurring and persistent large-scale patterns of pressure and circulation anomalies that span the globe. The two we will highlight are the Madden-Julian Oscillation, or MJO, and the El Niño Southern Oscillation, or ENSO, and its effects. The MJO is an intraseasonal fluctuation occurring in the tropical Indian and Pacific Oceans. It is responsible for the majority of weather variability in these regions and results in variations in several important atmospheric and oceanic parameters. The MJO is characterized by eastward propagation of regions of enhanced and suppressed tropical rainfall, primarily over the Indian and Pacific Oceans. Displayed is the RMM diagram. It is used to track and forecast the phases of the MJO. The MJO has 8 phases that it can cycle through when it is active. Depending on the strength and phases of the MJO, atmospheric anomalies will present themselves in various locations with wide-ranging impacts. The MJO is quite variable with periods of moderate to strong activity, followed by little to no activity. Let's look at how the MJO progressed over the last month and a half. In mid-March, as you can see, we observed an extreme high amplitude of the MJO for phase 7 and 8, which then normalized as it propagated eastward for phases 1, 2, and 3 during the month of April. The graphic on the right indicates the anomalous precipitation pattern expected with these respective phases. Contrast that with the current position, and you can see here the MJO is now relatively inactive as it remains within the center of the circle and is forecasted to remain inactive for at least the next week. The 14th Weather Squadron also uses this information to compile our Pacific Tropical Convective Forecast that is shown here. This forecast product is updated weekly and can be found on the CMAP webpage. Using the RMM diagram along with other model predictions, we are able to get an idea of what to expect for our forecast. We also evaluate the ENSO conditions to determine the effect on our forecast period. El Niño is characterized by a positive oceanic Niño index, or ONI, of greater than or equal to positive 0.5 degrees Celsius, while La Niña is characterized by a negative ONI less than or equal to negative 0.5 degrees Celsius. By historical standards, to be classified as a full-fledged El Niño or La Niña episode, these thresholds must be exceeded for a period of at least 5 consecutive overlapping 3-month periods. The ENSO condition is in El Niño status with positive equatorial sea surface temperature anomalies currently being observed across the Pacific Ocean. Over the past month, there has been an increase in subsurface temperatures, enhanced convection over the dateline, and increased persistent low-level westerlies, all which support the El Niño condition. There is an approximately 60 to 70% chance that those conditions will continue into the Northern Hemisphere autumn. Looking at the International Research Institute, or IRI, and CPC plume of model ENSO predictions, we can see that the majority of the models are predicting that the sea surface temperatures in the Pacific will continue to be at least 0.5 degrees Celsius higher than normal into November, December, and January. Although effects of El Niño are typically the strongest the winter after the onset of the event, El Niño generally brings a suppressed Atlantic hurricane season as well as a more active tornado season for North America. 2015 winter will likely bring cooler and wetter conditions to the southeast United States and warmer conditions to western Canada and southern Alaska. California will likely see wetter conditions bringing a relief to the drought conditions. Let's look at how these oscillations impacted global temperature trends over the past month. As you can see, the western United States continues to be warmer than average as typical with El Niño conditions. This is expected to continue into the summer. In our last webinar, we noted that the North Atlantic Oscillation correlated well with the warmer than average temperatures in Asia. This correlation continues. Looking at the precipitation trends from mid-March through mid-April, you will see connections with the phases of the MJO and ENSO in the precipitation anomalies. As previously mentioned, the MJO brought above-average precipitation to India. The ENSO brought wetter than average conditions to Mexico and continued drier than normal conditions in Madagascar, the western United States, southern Central America, and northern South America. Let's reference another one of our monitoring products to take a closer look at the precipitation trends in South America. When looking at the trend plot using the KMZ snapshot located on the CMAP page under Trends, we can see in northern Venezuela the drier than normal conditions. The solid green line, which depicts the cumulative precipitation this year, is well below the dashed green line, which depicts the normal cumulative precipitation. With these precipitation trends in mind, let's take a look at the global drought conditions. Drought improved slightly across the globe. Most of Central and Eastern Europe showed improvement, especially near the Black Sea. Drought conditions continued in Asia, especially around Mongolia and northern India. Africa remains entrenched in drought near the Horn of Africa, specifically in Kenya and southern Somalia. Equatorial Africa showed some improvement. Drought conditions continue in southwest and southern plains of the United States. Drought conditions are expected to improve slightly over the next 5 months in northern India and as well as the United States. Let's again put the spotlight on South America. Notice the pockets of intense drought in Venezuela, Brazil, and in the Andes Mountains. Next, we will look at our long-range outlook for South America to see what to expect over the next 1 to 3 months. As you can see in our latest South America long-range outlook, temperatures in the tropics continue to be above average due to El Niño conditions. Model guidance shows temperatures could be up to 5 degrees Fahrenheit above average in the Andes Mountains. El Niño conditions are also suppressing convection in northern Brazil, continuing the previously mentioned drought conditions. However, in the Andes Mountains, El Niño has led to a recent surplus of precipitation, which, coupled with the drought conditions, has resulted in numerous landslides. Based on the skill masking methodology, the surplus precipitation is not shown on this graphic, but with El Niño conditions expected to continue, the landslide risk remains elevated for the next 90 days. If you'd like to see a more detailed forecast for a particular location, please click on the CMAP graphic on our webpage to reference our regional long-range outlooks or LROs under the Outlook section, and our drought products under the Drought section. Another forecast tool that is currently in development will be found within our SITREP, a product that we introduced during the last webinar. In the coming months, we are transforming that product to not only include the current events for each COCOM, but also a look at what to expect for the month ahead. For example, June SITREP would include highlights and conditions for that month, but also a general forecast of temperature and precipitation for the month ahead. In the previous webinar, we also talked about the snow monitoring products the team produces. If you check out our webpage, you will notice that we have added a new snow monitoring region evaluating the Tajikistan and Kyrgyzstan watersheds. This bi-weekly snow assessment report follows the same outline as the others, providing a high-resolution snow-covered area analysis and a watershed-specific season-to-date total of snow water equivalent, or SWE. The volumetric SWE is useful to predict the potential for snow melt flooding and reservoir or dam impact. Now, Tech Sergeant Monk will review some recent tailored products. Hello, I'm Tech Sergeant Monk, and I'll be highlighting some SARs from this last quarter. To begin, I'm going to start with a unique support request. Sometimes a customer has an idea of basic weather parameters like temperature and winds, but does not necessarily know that we can provide more complex or custom parameters. This SAR deals with military working dog research. A U.S. Army researcher is studying military working dog deaths related to mesenteric torsion in large dogs. This often fatal condition is caused when a canine's intestines twist on itself, shutting off blood flow to the intestines and other tissues, which in turn causes shock, abdominal pain, vomiting, and death. This investigation involved 56 military working dog deaths throughout Europe, South Korea, and the U.S., which caused the researcher to question if the events correlated with weather conditions. This is where our expertise played a critical role in not only guiding the researcher's selection of weather criteria, but also determining station locations and timelines. We provided 3 days of forensic data from our archive that included temperatures, barometric pressure, humidity, heat index, and wind chill for 38 locations. This investigation is still ongoing and hopefully will help assess risk and possible mitigation efforts for mesenteric torsion. Next, we worked on an unmanned aircraft systems UAS pilot to provide a side-by-side weather analysis between a site he was very familiar with, Syracuse, New York, and compared that location to several sites across PACOM, including China, Japan, Korea, and the Philippines. He was interested in understanding how Syracuse UAS flying weather compared to 7 other sites, so he could better understand expectations of weather-related attrition rates. We designed a go, no-go stoplight chart that highlights impacts of 10 different criteria. An example is on this slide. This turns out to be a great way to understand the unknown via a known entity like Syracuse. Our statistics helped him estimate how many days per year and the percentage of time flight ops could be affected by weather. In turn, this information was the weather baseline for a remote piloted aircraft strategy rewrite focused in the PACOM theater. Finally, let's discuss a recent rule of thumb SAR. Every forecaster probably has experience with a rule of thumb based on a precursor condition, yielding a preset outcome. These are often made using experience of others gained from years of anecdotal evidence, but many are from solid meteorological science. Unfortunately, most rule of thumb of either type, anecdotal or scientific, that we analyze are not valid forecaster tools because some seldom verify at all, while many may occasionally verify, but are often offset sharply by high to very high false alarm rates. Our experience also shows that less than 5% of the thousands of rule of thumb we analyzed over the years have any merit. We recently worked on a rule of thumb SAR based on upper level pressure gradients that compared 700 millibar height differences between 2 Rocky Mountain locations. It was used to determine an increased probability of surface wind speeds exceeding 25 knots. This type of rule of thumb is very straightforward and easily verified with algorithms. This rule of thumb verification showed that over the last 20 years, with over 240,000 observations, that the rule correctly forecasts onset of strong surface winds about 10,000 times. However, note that it also produced a combined false alarm and missed opportunities almost 45,000 times. This yields a false alarm rate of 70% and missed opportunities, meaning the rule did not trigger yet an event occurred 65% of the time. It's not our position to validate whether a weather flight accepts or rejects a rule like this, but in this case and most others too, other tools, especially the numerical models, likely have a better success rate than a rule of thumb. A weather flight ultimately must determine if they are willing to accept the associated false alarm and missed opportunity rates. A couple things to note. Rule of thumb synaptic
Base events like 2 hours after frontal passage, expect certain weather occurrences to happen, are essentially impossible for us to study using custom-built algorithms since we deal in raw station data and have no way to analyze charts. Rule of thumb synoptic-based situations need to be developed using eyes on charts and are best left done at a weather flight. Additionally, we can validate a rule of thumb, but we don't have any mechanism to develop them from scratch. These are just a few examples of what our climate analysis team can do to provide you with what data you need. An important thing to keep in mind is that we generally can help you better if we have as much information as possible and we know what you are trying to do. If you need to submit a SAR, go to https://www.climate.af.mil and hover over the Request Support tab and click on Submit Support Request. The form will load, fill it out, and send. We look forward to hearing from you.
All right. Thanks, Airman Phobes and Sergeant Monk for that. While we're talking SAR support, I wanted to highlight a new section that we've just introduced on our website. So if you go to our homepage, www.climate.af.mil, and you'll see here under featured products buttons, and then underneath our search videos function, we've added a recent SARs button, and that'll take you to a page where first thing that pops up there is the SARs that we've accomplished over the last 1 to 2 months. So just a quick snapshot map there, and then also our video that we put together for this quarter. So this is a very preliminary type of effort that we've just introduced. Stay tuned and come back and check this page out. We'll be updating it regularly, adding products and such that we think will be useful to you. So check that out over the coming months. So to conclude our webinar today, again, we've got a guest presenter on the line, one of our users, Bill Roeder from the 45th Weather Squadron at Patrick Air Force Base is going to talk about how they use Climo to support their space mission down there at Cape Canaveral. So, Bill, you on the line? Okay, great.
Thank you very much for the opportunity. Applications that we use at the 45th. Success from the start. Our climatology applications break into 4 major categories. The first and largest one for the best weather. This is not just giving them the best date and time for their weather thresholds, but also a robust date and time. What if their operation starts late? What if it runs longer than expected? We take that into account, and so the customer, based on their confidence in their option. Mission planning, you may be familiar with the Orion, the capsule as part of America's return to manned spaceflight. We had our first successful test launch back in December, but we had 2 major ground transport operations where we had to move the capsule and then the capsule and the booster between 2 pairs of facilities. They had various sensitive temperature and wind frequency of exceedance and durations to be concerned with, and we helped them plan the best date and time. And in this case, giving them the robust date and time was important because they did have some delays, but by having picked the best option, they were able to minimize the weather impacts and get the missions done on time. Another example is the Webb telescope, the upcoming replacement for the Hubble Space Telescope. That's scheduled to launch in 2018. This is launching out of French Guiana in South America at the European Kourou launch pad. And when the payload is out at the launch pad weeks before launch, it's very sensitive to induced current damage from nearby lightning strikes. Unfortunately, in that location, we don't have very good lightning climatology yet, but we were able to use the satellite sensors on some research satellites to develop a new climatology and help NASA schedule for the best time to avoid the lightning impacts. Another example is the Space Launch System, another part of America's return to manned space flight. In designing the ConOps and the vehicle itself, they had various wind exceedance and duration frequencies, and so we were actually able to help design that program. Do I have a cool job or what? Another example, last year we had some submarine launch ballistic missile tests. They wanted to avoid certain upper level wind conditions. We developed an interpolation tool for the range reference atmosphere, the RAYUP climatology, to allow us to provide that interpolated levels faster and with better reliability. If we move to the next slide, our second major Climo application is project management. One example is the recent new AFTAC building, a $158 million project. They were interested in frequency of wind speed exceedance from hurricanes to design the proper structural limits for the building. We were able to provide that, and we actually took into account possible climate change because the building is going to be there for probably 50 years. And while doing this, we discovered they had not considered storm surge. So we were able to advise them on that, and they actually changed the design of the building. They trucked in who knows how many tons of soil to build up the ground level 3 feet to give them a buffer in case there's any flooding. And their supercomputers on the ground floor, they put those on risers to mitigate the impact even if flooding does occur. Another example of project management or program management, we're installing a new set of lightning detection systems, and one of our sites was having a problem with wet soil. This is occurring during the winter, our normally dry season, but using medium range forecasting, we were able to point out that even though it's a dry season, there's still going to be more rain than normal, so we were able to get the vendor to come up with a water mitigation plan. Our third major application, developing new forecast tools and techniques. Some people may not consider this climatology. It's certainly not traditional, but we're using past observations to develop new forecast techniques, makes them objective and helps us optimize their performance. One example is we've recently upgraded our local minimum temperature tool, and we improved the RMSE, the root mean squared error, by over 64%. Finally, the fourth major application, fortunately the smallest of the least frequent of the applications, is incident investigation. One example is this past summer, we were having some lightning strikes near key facilities that had peak currents much stronger than normal. Customers were asking us, how frequently does lightning achieve this strength? Well, we developed a new interpolation, tool that gives us, you put in the desired peak current, and it'll tell you the frequency of achieving those peak currents. That is just a very brief taste of climatology applications at the 45th Weather Squadron. For those who'd like to know more, my contact information is at the bottom of the slides. And I'd like to finish by giving a little kudo to 14th Weather Squadron. Many of these projects would not be possible without their custom-tailored climatology support. And in particular, I'd like to give a shout-out to Jeff Zontner, one of my main contacts up there. He does absolutely stellar work helping us help the American space program. And that's all I have for you today.
All right, thanks a lot, Bill. We really appreciate you taking the time to share with how you've been able to use Climo to support your mission down there. And I just also want to just take this time to put a plug in. You know, we're always looking for ways to better highlight and incorporate support to our users. So if anyone out there has something similar they'd like to present, a success story, or just a general application of climatology services to support your mission, please let us know, and we'll work with you to feature you in